This is the EdExcel GCSE 91 Maths Paper 2, which is a higher paper and it's from the 2023 series. Question number 1, part A, we have to work out the value of 25 subtract the square root of 43.87 over 6 plus 2.1 squared. We have to write down all the figures on your calculator display. If we key in this calculation, we begin by pressing the fraction button. We have 25 subtract the square root of 43.87 divided by 6 plus 2.1 squared, and working this out we get 1.76527923. Part B, we have to work out the value of the reciprocal of 0.625. Well, this is given by 1 over 0.625, and if we work this out, 1 over 0.625 is 8 over 5, which is 1.6. So the reciprocal of 0.625 is 1.6. Question 2, we have to write 60 as a product of its prime factors. Well, we begin with the 60, and 60 we can rewrite as 2 multiplied by 30. So we've got this 2, and we're multiplying this by 30, and the 30 we can rewrite as 2 times 15. So we've got this 2 times this 2, and we're multiplying this by 15, and 15 we can rewrite as 3 times by 5. So 60 is equal to 2 times 2 times 3 times 5. We've expressed 60 as the product of its prime factors. Question number 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 20 is half of 48. Is Helen correct? You must give a reason for your answer. Well, we've got this ratio 1 to 2. We need to split the total 48 in this ratio 1 to 2. So what we have to do is divide the 48 by the 1 plus 2. We have to divide 48 by 3. So she's wrong because red is a third of the total, and if I work out a third of 48 we get 16, so 16 is red. Question number 4, we have negative 2, which is less than or equal to n, which is less than 5. N is an integer. For part A, we have to write down the greatest possible value of n. Well, if I think about the possible values of n, I've got minus 2, minus 1, 0, 1, 2, 3, and 4. Can't include the 5. So the greatest possible value of n is 4. Part B, on the number line below, show the inequality negative 4, which is less than or equal to m, which is less than 1. Here is the inequality represented on a number line. We have a filled circle representing the weak inequality and an empty circle representing the strong inequality. The values are shown between minus 4 and 1. Part C, solve 2 over 5g subtract 4 is less than 6. Our first step is to add 4 to both sides. That leaves us with 2/5 g equals 10. If I multiply both sides by 5, we have 2g equals 50, and if I divide both sides by 2, you will find g to equal 25. Question number 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres squared greater than the area of the rectangle. We have to find the value of x. Now with this triangle, we've got a base of 8 and a height of 6x. With this rectangle, we've got a length of 5 and a width of 4x subtract 1. To begin with, the area of the triangle, that will equal 1/2 times by the 6x times by the 8, and this simplifies to 24x. The area of the rectangle, we've got the 5 multiplied by the 4x subtract 1. 5 times 4x is 20x. 5 times negative 1 is negative 5. We know that the area of the triangle is 10 centimetres squared greater than the area of the rectangle. So we've got the area of the triangle, 24x, that's equal to the area of the rectangle, 20x subtract 5, plus the 10. So let's solve this equation. 24x subtract 20x is 4x. Negative 5 plus 10 is 5. So x is equal to 5 over 4. Question number 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper recycled to the weight of glass recycled is 12:7. We have to calculate the weight of the glass the family recycled. First of all, we can find out the total weight of the paper and glass. That's equal to the 57% of the 800, and if we work this out, we have 0.57 times 800, which is 456. So the total weight of paper and glass is 456 kilograms. Now, we've got this ratio of P to G being 12:7, and I've represented that on a diagram here. And we know that the total is 456. So I've got the 12 plus the 7, which is 19 parts. So if I divide this value by 19, I get 24, which means each part is worth 24, as we see in blue. So the total for P, that's equal to 288, and the total for G is 168. So we have 168 grams. Question number 7. A number D is rounded to one decimal place. The result is 12.7. We have to complete the error interval for D. Well, we have 12.65, which is less than or equal to D, which is less than 12.75. Question number 8. Tasmin buys a house with a value of £150,000. The value of Tam's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house is increased by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. Well, if I think about Tamsin's house, we've got this 150,000, and I multiply this by 1.04, which represents a 4% increase, and I raise this to the power of 2 because I'm looking at a time period of 2 years. So I've got 150,000 times 1.04 squared, and it turns out the value of her house is £162,240. If I take a look at Rachel's, I've got this £160,000, and I multiply this by 1.015, which represents an increase of 1.5% each year, and I raise this to the power of 2 because I've got a time period of 2 years. So I've got 160,000 times 1.015 squared, and it turns out I get 164,836. Question number 9. The cumulative frequency table gives information about the ages of 80 people working for a company. We've got the age in years and the cumulative frequency. On the grid opposite, we have to draw a cumulative frequency graph for this information. So we've got our first point, shown here, our next point shown here, our next point shown here, the next point shown here, and our final point shown here. And if we join these up, we end up with this as our cumulative frequency graph. We now have to use our graph to find an estimate for the median age. Half of the 80 is 40, so if I draw a line from 40, like so, and then draw a line down from this point, you can see we end up with a value of 37 for the median. So we have 37. Question number 10. A bias dice is thrown 60 times. The table shows information about the number that the dice lands on each time, and that's shown here. We've got the number on the die that's displayed, and then the frequency of landing on that particular number. Gethin throws the dice twice. For part A, we have to work out an estimate for the probability that the dice will land on a 6 both times. Well, the probability of landing on a 6 is 15 over 60, so the probability that we land on a 6 both times, we've got 15 over 60 times 15 over 60, which is a 16th. Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? Well, we've got more trials, and that's because we have a more reliable estimate. Now, before we had 60 trials, so if we have more trials than 60, that means n must be greater than 60 for a more reliable estimate. Question number 11, we have to use algebra to solve the simultaneous equations 2x plus 6y equals 5 and 3x subtract 4y equals negative 12. Well, if I multiply this first equation by 4 and the second equation by 6, that will make the y's the same and would have opposite signs. So multiplying the first equation by 4, we have 8x plus 24y equals 20, and multiplying the second equation by 6, we end up with 18x subtract 24y equals negative 72. We've got the same number of y's but different signs, so we need to add the equations. 8x plus 18x, that's 26x, and 20 plus negative 72, that's negative 52. So 26x is equal to negative 52, which means x is equal to negative 2. Now that I know what x is, I can find out what y is. I can substitute into this first equation. I've got 2 times by x, so I've got 2 times negative 2, plus 6y equals 5. So I've got negative 4 plus 6y equals 5, which means 6y is 9, which means y is equal to 3 over 2. Question number 12, the points A, B, C and D lie on a circle with centre O. A, B, C, D is a rectangle, as we see here. AB is equal to 8 centimeters and BC is equal to 10 centimeters. We have to work out the circumference of the circle, give your answer correct to 3 significant figures. Now, what we can do to find the circumference of the circle is first of all find the diameter, and the diameter will be given by AC, and we can find AC using Pythagoras. So the diameter AC, that's equal to the square root of the 8 squared plus this 10 squared, and if we work out what this is equal to, we have the square root of 8 squared plus 10 squared, which is 2 root 41. So therefore, for the circumference, we multiply pi by this diameter of 2 root 41. So if I multiply this by pi, I get 40.2 centimeters to 3 significant figures. Question number 13. ABC is a triangle, as we see here. And what we have to do in this question is calculate the size of the angle BAC to 1 decimal place. Well, the angle BAC is this angle here. Now let's think about what I've got. I've got an angle here and a side here, and I've got this side here. What I can do is find out what this angle is. Let's just call it Y for now. And I can find out what this angle Y is using the sine rule, and then use the fact that angles in a triangle are up to 180 to find out the angle X. So I've got the sine of Y over 15 equals the sine of 70 over 18. So let's rearrange for the sine of y. For the sine of y, that's equal to 15 multiplied by the sine of 70 over 18, which is 0.783, etc. So if I inverse sine this, I can find out what y is. Y is 51.5 degrees to 1 decimal place. So I've got angles in a triangle which add up to 180. So I've got x plus this 51.5 plus the 70 equals 180. So if I find out what x is 58.5 degrees. Question number 14. We have to show that x squared subtract x subtract 6 can be written in the form ax plus b over cx plus d, where a, b, c and d are integers. We've got our expression, which we can factorize the numerator and the denominator. If I factorize the numerator, I end up with x subtract 3 multiplied by x plus 2. And if I factorize the denominator, I end up with 2x plus 1 multiplied by x subtract 3. Now the x subtract 3's cancel on the top and bottom, leaving us with x plus 2 over 2x plus 1. Question number 15. Here are the first 4 terms of a quadratic sequence. We've got 3, 9, 17 and 27. We have to find an expression in terms of n for the nth term of this sequence. Well, if I find the difference between each of these terms, we've got the difference between 3 and 9 being 6, the difference between 9 and 17 is 8, and the difference between 17 and 27 is 10. If I now find the difference between these, the difference between 6 and 8 is 2, and the difference between 8 and 10 is 2. So now that my second difference is 2, what I need to do is divide this second difference by 2. So I've got 2 divided by 2, which is 1. So A is equal to 1. So I've got my 1n squared terms, which is 1, 4, 9, and 16. I've got my sequence 3, 9, 17, and 27, and what I can do now is work out the sequence, subtract the 1n squared terms. 3 subtract 1 is 2, 9 subtract 4 is 5, 17 subtract 9 is 8, 27 subtract 16 is 11. If I find the difference between each of these, I've got the difference here being 3, the difference here being 3, and the difference here being 3. So if I find the 0th term, I need to do the inverse of plus 3, which is subtract 3. 2 subtract 3 is negative 1, which means I've got a 1n squared plus 3n subtract 1 as my quadratic sequence. Question number 16. The histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. We've got the number of hours used and the frequency density. 28 students used their phones for between 30 and 40 hours. 24 students used their phones between 40 and 60 hours. We have to use this information to complete the histogram. We've got a frequency and we've got a class width. We can find out the frequency densities. We've got 28 divided by 10, which is 2.8. So the frequency density here is 2.8. And if I add this to the diagram, we've got that information shown for this bar. And then for the 24 students, I've got my frequency, which is 24, and my class width, which is 20. So my frequency density is 2.4. And if I find where 2.4 is here, 2.4 is here. So I need a class width of 20 and a frequency density of 2.4. So here is the remaining box. No student used their phone for more than 60 hours. We have to work out the total number of students. So what we need to do here is work out the frequencies, and I can do this by considering the area of a rectangle. Let's first of all find each of the frequency densities. Here I've got a frequency density of 1.6. Here I've got a frequency density of 3.6. So now here I've got 20 times 1.6, which is 32. Here I've got 10 multiplied by 3.6, which is 36. I've got the 28, which was given before, and here that was 24, which was given before. So to find out the total number of students, I need to add all these numbers together. So I've got 32 plus the 36 plus the 28 plus the 24, which is 120. Question number 17, part A, we have to show that the equation x to the 4 subtract x squared subtract 5 equals 0 can be written in the form x equals the 4th root of x squared plus 5. The first thing we can do is add x squared plus 5 to both sides. That leaves us with x to the 4 equals x squared plus 5. And if I take the 4th root of both sides, we can therefore conclude x is equal to the 4th root of x squared plus 5, which is what we wanted to show. Part B, starting with x naught equals 1.5, we have to use the iterative formula xn plus 1 equals the 4th root of xn squared plus 5 3 times to find an estimate for a solution of x to the 4 subtract x squared subtract 5 equals 0. So I've got x naught equals 1.5. To find x1, that's equal to the 4th root of x naught squared plus 5. So I've got the 4th root of 1.5 squared plus 5, and if I work this out, well here, what we can do is type in the 1.5 and store this into the answer function. Then here we type in the 4th root of our answer squared plus 5. So working this out, I get 1.640, etc. x2, that's equal to the 4th root of x1 squared plus 5. So I've got the 4th root of 1.640, etc. squared plus the 5. And if I press equals again, I find my next solution to be 1.665, etc. And x3, that's equal to the 4th root of x2 squared plus 5. So I've got the 4th root of 1.665, etc. squared plus 5. And if I press equals again, I end up with 1.669. Question number 18. 2a to 5c is equal to 6 to 25. 4b to 7c is equal to 20 to 21, we have to show that a plus b to b plus c is equal to 17 to 20. Now, what we can do is make the c's the same. I've got 5c here and 7c here. The lowest common multiple of the 5 and 7 is 35, so I want a 35c for both ratios. Now, how did I go from the 7c to the 35c? Well, I multiplied by 5, so 4b times by 5 is 20b. How do I go from the 5c to the 35c? Well, I multiply by 7, so 2a times 7 is 14a. And similarly, if we make the c's the same, we want the 25 and the 21 to have the same multiple. So, if I do 25 times 21, I get 525. So those bits are the same, which correspond to the 35c. How do I go from the 21 to the 525? Well, I multiply by 25, so 20 times 25 is 500. How do I go from the 25 to the 525? I multiply by 21. 6 times 21 is 126. So I've got 14a to 35c equals 126 to 525, and 20b to 35c is equal to 500 to 525, which means the ratio of 14a to 20b to 35c is equal to 126 to 500 to 525. Now what I want to do is find the ratio a to b to c, so I can work out a plus b and then b plus c. Well, here I've got 14a equaling 126, so if I divide 126 by 14, I get 9. Here I have 20b equals 500, so to find out what 1b is, 500 divided by 20 is 25. And here I've got 35c equals 525, which means 1c is equal to 525 divided by 35, which is 15. So a to b to c is equal to 9 to 25 to 15. Which means a plus b, that's equal to the 9 plus the 25, which is 34, and b plus c, that's equal to 25 plus 15, which is 40. So the ratio a to b plus c, that's equal to 34 to 40, and if I divide both sides by 2, I get 17 to 20. Question number 19. ABC is a right angle triangle. AB is 9.3 centimeters to the nearest millimeter, and AC is 12.6 centimeters to the nearest millimeter. We have to calculate the lower bound for the size of the angle marked X. You must show you're working. Well, I can work out X by using inverse sine of the opposite 9.3 divided by the hypotenuse 12.6. Before that, I need to work out the error intervals of AB and AC. The error interval of AB, we've got 9.25, which is less than or equal to AB, which is less than 9.35. And if I think about the error interval for AC, I've got the lower bound being 12.55 and the upper bound being 12.65. So for me to work out the lower bound of sine x, that's equal to the 9.25, the lower bound of the opposite, divided by the upper bound of the hypotenuse, 12.65. So if I work out what this is equal to, 9.25 divided by 12.65, that is 0.731, etc. Which means the lower bound of x is equal to the inverse sine of this 0.731, which is 46.98, etc. degrees. Question number 20. We have OT, which is equal to A, and we've got RT, which is equal to B. We have M, which is the point on OR, such that the ratio OM to MR is 2 to 3. We have to express MT in terms of A and B. So we want to start at M and finish at T. And for us to do that, what we can find is the vector OR before anything else. And then we can use this ratio. So the vector OR, I'm starting at O, I want to finish at R. So I can go O to T, and then R. Then I can go from T to R. So that's equal to A subtract B. Now that I know what OR is, I can find out what OM is. Using this ratio, that's equal to 2/5 of OR. Now I know what OR is, that's A subtract B. So OM is equal to 2/5 multiplied by A subtract B. Now I want to go from M to T. So now that I know what OM is, I can now find out what MO is. So MO is the reverse of this, which is equal to 2/5 multiplied by B subtract A. So I know what MO is, I know what OT is, so therefore MT, which is what I need to find, that's equal to MO plus the vector OT. So I know what MO is, that's 2/5 times B subtract A, and I add on to this OT, which is just A. So let's try to simplify this. In terms of my A's, I've got negative 2/5 plus 1, so that's 3/5 A, and then I've got the 2/5 B. And if I factorise out a 1/5, I would have 1/5 multiplied by 3A plus 2B. So that's what the vector MT is equal to, 1/5 times 3A plus 2B. Question 21, here is a graph of y equals f of x. Part A, on the grid below, we have to draw the graph of y equals f of x subtract 4. Now here is the graph of y equals f of x. I need to move this graph 4 units down. So I've got 1, 2, 3, 4 units down. So here is the graph of y equals f of x subtract 4. Now we have to draw the graph of y equals f of minus x. Here is the graph of y equals f of x, and what I need to do is reflect this in the y-axis. And reflecting in the y-axis, we end up with the graph positioned here. So here is the graph of y equals f of minus x. Question number 22, there are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random 1 pen from the box. She recalls the colour of the pen and then replaces it in the box. Rita does this n times where n is greater than or equal to 2. We have to write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. So if we've got x red, that means we've got 4 times as many blue, which means we've got 4x blue. So the probability of getting a red will be 1 over 5, and the probability of a blue is 4 over 5. So we want the probability of getting at least one blue and at least one red. So that's equal to 1 subtract the probability of getting all of them blue, subtract the probability of getting all of them red. So I've got 1 subtract, now the probability of all of them blue, remember I'm doing this process of taking a pen from the box n times, so I've got 4/5 to the power of n. So this is all the pens being blue, and then I subtract all the pens being red, so again I've got 1/5 to the power of n. So this is the expression we require. Question number 23, here are 3 similar triangles, ABG, ACF and ADE, so we have those 3 similar triangles as shown in the diagram. ABCD and AGFE are straight lines. We've got the ratio of AB to BC to CD being 1 to 2 to 3. We have to show that the area of AGB to the area of the BCFG to the area of CDEF is equal to 1 to 8 to 27. So first of all, here are those individual triangles. Now if we've got this ratio of 1 to 2 to 3, if we've got AB being 1, then AC will be 2, will be 2 plus the 1, and AD will be the 1 plus the 2 plus the 3, which is 6. Now, to go from the triangle ACF to the triangle ADE, we multiply by 2, and to go from the triangle ABG to the triangle CF, we multiply by 3, and to go from the triangle ABG to the triangle ADE, we multiply by 6. So our length scale factors are shown. So the area of the triangle AFC, we can use our scale factor to help us find this. That's equal to 3 squared, because my length scale factor is 3, so my area scale factor 3 squared, multiplied by the area of AGB. So I've got 9 times the triangle AGB. So now I can find BCFG. BCFG is found by this big triangle, subtract that little triangle. So I've got the triangle AFC, subtract the triangle ABG. Now the triangle AFC has an area of 9 AGB, and I'm subtracting from this the area of the triangle ABG, leaving me with 8 times the area AGB. And the area of the triangle ADE, similarly, that will equal 6 squared, because I've got a length scale factor of 6. So my area scale factor is 6 squared, multiplied by the area of AGB. So I'm going from this triangle to this triangle. So I've got 36 times AGB. So now I can find out what CDEF is, and that's found by this big triangle ADE, and I'm going to subtract from this AFC. But I've already found out what AFC is over here. So I've got 36 AGB, subtract 9 times AGB, leaving me with 27 AGB, which means the ratio of ABG to BCFG to CDEF is equal to, well, I would have ABG being the 1 as my area, BCFG, I had 8 of those ABGs, and the CDEFs, in terms of the AGBs, I've got 27 of those. So I've got the ratio being 1 to 8 to 27, which is what we wanted to show. Question number 24. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. We have to find, in terms of A, an expression for the area of the shaded shape. Give your answer in the form P times 2 plus root 2 A squared, where P is an integer. You must show all your working. The first thing you will notice is we've got 4 of these identical triangles, and we know that each octagon has a side of A, which means here we have A, and here we have A, and similarly here we have A, and we have A here. So we have A in the positions shown. What we can do is find out the area of one of these triangles. You can think of this to be, if we rotate one of them, we would have this situation here. We've got a right-angled triangle. The reason that helps us is because what we can do is find out the area of one of these rectangles. So the area of one of these triangles, well, I've got my base being A and my height being A, so the area of one of these triangles is a half A squared. Now, the next thing we need to do is find out the area of this square. So for me to find out the area of the square, what I need is the length of the square. And before I do anything else, what I can do is find out what this length here is. So what I need to do is find out what this length is, which is the same as this length, and using Pythagoras, that's equal to A squared plus A squared square rooted, which is equal to the square root of 2A squared is just equal to root 2A. So we have here a value of root 2a. So if here I've got root 2a, I've also got this length here, which is a, and here I've also got a, which means for this square here, we can find the side length. So the length of the square is given by a plus a plus the root 2a, and if we work out what this is equal to and simplify it, we have 2a plus root 2a. So the area of the square, that's equal to 2a plus root 2a squared. So I know the full length, which is 2a plus root 2a, and I'm squaring all that to find the area of the square. So that's equal to 2a plus root 2a multiplied by itself. Now if I expand this out, 2a times 2a is 4a squared, 2a times root 2a is 2 root 2a squared, root 2a times 2a is 2 root 2a squared, root 2a times root 2a is 2a squared, and adding all this up, we end up with 6a squared plus 4 root 2a squared. Now I can find the area of all four of those triangles. Because I know the area of one triangle, I need to multiply 4 by the area of one of those triangles, which is a half a squared. So the area of all four of those triangles is 2a squared. So the total area of the square plus those four triangles, we've got the area of the square, 6a squared plus 4 root 2a squared, plus the area of the four triangles, 2a squared, and working this out we get 8a squared plus 4 root 2a squared. We need to simplify this. From the 8 and the 4 I can factorise out a4, leaving me with 2 plus root 2, and then I can also factorise out the a squared. So the total area is 4 times 2 plus root 2 multiplied by a squared.